Okay, welcome. This is section 1.1 of analyzing categorical data for AP statistics. I'm Todd Tiddell. In the last section, we took a look at an introduction of what variables were, categorical, quantitative. This time we're going to be analyzing the categorical data. Okay, and so we'll look at bar graphs. We'll identify what makes graphs of categorical data deceptive, and we'll calculate. And then in part two, we'll calculate and display two margin distributions. So in the first part, we're just going to do the first two learning objectives. Okay, so on page 8 of your text, you see there's some data from the radio stations formats, and these are the categorical values placed individuals into one of the several groups of categories. So they took some data of radio stations throughout the U.S. and they placed them in these categories. The first one on the frequency table on the left shows the actual count of stations in each of the formats. There is a format at the bottom there called other formats that didn't fit in the main ones. And then you can see there's a total of 13,838 stations. The one on the right is a frequency table, and so you can see we'll figure out how that works. So we have on the left, we had the format is the variable. As we're looking at the categorical variable of the types of radio station, or the format radio station. The values are which one of the categories they put them in. The count is the column on the right side of that frequency table, so the count of them. And on the relative frequency, they took the data and they calculated the percent of stations. So you can see that here we have 11.2%. What does that mean? 11.2% of what? Yeah, if you were saying of the total, then you're correct. So they the frequency total is was the actual count, and then the relative frequency is calculated by taking finding a percent of the count. So if we take 1,556 and divide it by 13,838, and we get approximately 11.2. These are all rounded to one decimal place, and you can see that calculation is pretty simple to do. But notice that at the bottom here we have a total of 99.9%. The reason for that is because when you round to decimal places, sometimes you get what's called a round-off error. It's okay in statistics to get round-off errors. It's acceptable. So we don't worry about it as long as it's not too far off. If it's really far off, then we should be concerned with that. Okay, so when we display, now we want to display the categorical data. Frequency tables can be difficult to read because if you just look at this, you sort of glaze over after you start reading these numbers, and maybe you can start processing, trying to find the biggest one or the smallest one, or things like that. Sometimes it's easier to use a bar graph or a pie chart. So the frequency table works well for using a bar graph, because then these are actual counts, and now it's a little bit easier to show, there the news talk was the largest count, and then the next one was country and religious and so on. It looks like other and adult contemporary were about the same, and you can look at the data and see that, but it's much easier to display a bar graph to see that. Now notice on the bar graph, you're going to be making lots of bar graphs in this course, but you've got the variable down here, and then the count goes up on this side, and then of course we get a title. The relative frequency table works well to make a pie chart, and we can see that these two are the same. Though what's difficult about this is the shading is difficult, right? And so it's hard to tell one blue from the next, and it might be difficult. I think it would be better if they would have done contrasting colors like reds and greens and things like that, so that it'd be easily tell. It's hard for me to tell whether this 9% is adult standard. I could peek back here, and yeah, adult standards were 9%. So, and then we could also assume that this is going to be in increasing order from top to bottom, and it's going to be going clockwise that way. Anyway, pie charts are a little bit easier to see. You grab it real quick to see that there's 16%, which is the biggest, and then these two are roughly the same. But notice that they rounded it to the nearest percent. Now, do you know how they made that pie chart? Yeah, well, maybe you do, but if you did it manually, you actually have to take each one of the percentages from the frequency table and then multiply it by 360, which is the number of degrees, and then measure out the angle that you get, and then to figure out the pi. In this course, we won't be doing a lot of those pie charts by hand. What we'll be doing is using our calculators to do that. Okay, so let's take a look at the example on page 9. This has to do with MP3 players. It's on the bottom of page 9. And you can see the data table is actually on page 10. And the question is who owns MP3 players? So they took some data, and they have age groups, 12 to 17. They found 54% of the group 12 to 17 owned MP3 players. 30% in the age group of 18 to 24 were also owned MP3 players. And so on. So what we're first going to do is we're going to make a bar graph out of it. And so if you have your notes, you can pause the video right now and make your bar graph. Okay, so I'm assuming that you made your bar graph, and it should look something like this, where we have the 18 to 24 down at the bottom. It's hard to see that because of this thing here. So notice that you try to get it as close as you can. There's 54, which is in between 50 and 60, and 30, which is right even with that 30, and so on. So would it be appropriate for us to make a pie chart out of this? Yeah, if you thought no, you're right, because we don't have 100%. If you add these up, we don't get 100%. We have clearly over, because 30 and 30 is 60, and 50 is well over 100% already. So the confusion part is why don't we have 100%? It's because they polled. There was another question in there. What is your age, and then do you own an MP3 player? So there's more data than it's actually showing here. But that's okay for now. We'll look at those kind of tables shortly. Okay, so now we're going to look at the difference between good and bad graphs. Bar graphs compare several quantities by comparing their heights of the bars that represent those quantities. Our eyes, however, react to the area of the bars as well as the height. And so when you draw a bar graph, make sure the bars are equally wide. It is tempting to replace the bars with pictures for greater eye appeal, but don't do that. Those are called pictographs, and those don't work so well. Maybe they can be cute, but they're not. And then you have to also watch the scales. Take a look at the top of page 11 with who owns IMAX, and you can see that the graph on the left, the previous computer, is either none or Windows or Macintosh, and they made that Macintosh so much bigger than the Windows computer. I don't know if they're actually those kinds of computers, but the picture is so much bigger, so it looks like it's so much more. If you then look at the bar graph down at the bottom, you can see that the bar graph shows that yes, it is bigger, but it's not as big, so much bigger as the picture shows. And then look at the two bar graphs on the middle of the page 11. You can see that there's something misleading about the two. And what do you think that is? Yep, the one on the left starts at 0, but the one on the right doesn't. So it makes the PC and the none so much smaller that it looks like it's almost non-existent. So let's try an example. Turn to page 22, and we're going to look at exercise number 17. Okay, so this scenario has to do with 30 students and the mode of transportation to school. They produce this pictograph. So they have walkers walking, buses bussing, cars carring, and just cycle or cycling. So why is this misleading? Well, if you notice that one bus represents 7 riders, whereas it looks like that's the same length as the walkers. One of the people represents 2 walkers, 2, 4, 6, though you have to look at the fine print over there, and each car represents 2 cars. I don't know how many people are in the cars. That's not anything that they're telling us. Could be 1 person, could be 5 or 6 people, and so it's really misleading by the size of the picture that they use. And which graph would be better? Yeah, probably a bar graph. And if you actually, you can sort of make a bar graph out of this by taking this and saying, okay, that's 6, and that's 7, that's 14 out there, and then this is 2, 4, 6, 8, 9. Let's see how much longer that is. It should be about right in here. And then this is only 1, so it should be much smaller. So this is what the bar graph looks like. Whoops, too many flips. And so the bar graph looks much better than that. Turn that off. Okay, so let's look at another example, and that's on page 22. Page 22, number 18, so it's just like that last one. And so how is this graph misleading? So if you thought, oh yeah, so we'll look at this scale is 196 to 208. So this is only 13. That only represents 13. And so this looks like it's so much less, but really it's 2, 4, 5 or so, right? And so it's not really even that small. So this story had to do with representing cholesterol, everything, as you can read the story. And then the question was, does eating oatmeal reduce cholesterol? The answer would be, well, yeah, it does, but it's not that big. Okay, so this is your assignment for part 1. So if you want to do that, then I will check your work in class. Okay, thanks for listening.